Hey everyone, and welcome back. This is the second video of today. This is Betweenness of Points. Okay, so here we have a line segment A, B, C essentially. So line segment AC. Now, when we're talking about between, it's pretty easy for you to see right here, and you'd probably say it yourself that B is between A and C. Okay, now understand that that has a little complication to it when it comes to geometry because we want to be more precise, and precision is key. Okay, so a couple notes before we really start into it is what I have here is I have kind of got this diagram split up a little bit different ways. So what this is referring to, this symbol right here, where it's up here, is we're talking about this segment right here, what the length of it is. Same thing if we were talking from B to C, right? This represents the length of BC, and this whole thing represents the entire length of AC. And we'll see some examples of that in just a minute. Some other important notes is that when I have just two letters together, 2 points together, this is referring to the measure of line segment AB. So some notational things really quick because I know it can get confusing. All right, when I'm talking about line segment, or sorry, line AB, right, I use the arrows on top with just the line over it. And so this is referring to a line. A line has no measure. It does have directions, or not. It's not really directional, right? But it does have, but it extends infinitely in all directions, and it's infinitely small. So this is line AB. Okay. If we were talking about just a chunk, so for example, A to C, okay, right? What we would do if we were just talking about a chunk, right? This would be AB, and this would be line segment AB. So now this is a measurable thing because we have two endpoints. We have A and B. Okay, and then of course our last one is AB, which is this actually talking about a measure. So some important things is anytime you see like a hat or something above 2 letters or 2 letters or 2 points or anything like that, please know that these are talking about geometric figures, right? And they have no value. So when I'm talking about the measure of something, right, I use these 2 letters, and this is actually this right here. This is a number. Okay, whatever this is a number. This is a measurable thing. It is a unit. Sorry, a unit of measure. Okay, so like for example, if I want to say the length of AB was 9, I could just say that AB is equal to 9. But I cannot ever say that line segment AB is equal to something. That does not work. Okay, so I can say something like this, but I cannot ever write that. Okay, that does not work. Okay, because this is a shape, this is a measure. Shapes don't equal numbers, measures equal numbers. Okay, important little note. So when we're talking about between, okay, understand that between kind of has two criteria when we were talking geometrically. So we can say point B is between points A and C if and only if, that's what that IFF stands for, is read as if and only if, A, B, and C are collinear, which we can tell that they are, and, right, if I take their segments, so if I take the length of AB and I take the length of BC and I add it together, that should give me the entire length of AC. Okay, and so an important phrase that I want you to remember for the next couple of weeks, right, is the sum of the parts equals the whole. Now that's going to be very, very important for other things coming later in geometry. So just remember that this phrase right here is going to save you. Okay, the sum of the parts equals the whole because the whole thing is AC. In order to get it, if I take AB and I add it to BC, that should give me the entire length of AC. Now, we don't use this theorem essentially, or this idea essentially to determine whether or not point B is between A and C. We're always going to assume that if I have 3 collinear points, that this one, we can say it's between, which means that this statement right here, right, is going to be true. That's more of how we use it. And let me just show you some examples to kind of say why. So I'm not going to do all of these problems. I'm going to do probably just the just number 1, 5, and 7. And then if you would like to do the rest and have me check your work, please go ahead and email me your work, and I will verify whether or not you got the answers correctly, and I can give you some constructive feedback. But if you just kind of follow along this video, it should help you explain a little bit and prepare you for the assignment that's coming. Okay, but if you just want a little extra practice, you can do all these other problems. All right. So for this first part, I just want to find the length that's indicated. Well, the length that's indicated that we don't know the measure of is this one right here. So before I begin, I can already assume that G is between F and H, and that because all of these 3 points are collinear. Okay, so because it looks that way, we can assume this. I'm sorry, that's not true. Don't ever just assume. There's very few things that we can just assume when it comes to geometry. In this case, if I have 3 points that look like they're on the same line, I can assume that they're on the same line. Okay, so I can assume that these 3 points are collinear. So because I know that they're collinear, I know G is between F and H. What I do know is that the next statement is true, and I always recommend that you guys set it up this way when you start. So I'm going to set it up just like I did with the previous one. That statement that I know is true. I know that the length of FG plus the length of GH is going to equal the length of the whole thing, which is FH. Again, sum of the parts equals the whole. Now you're probably going, well, what's FG? Well, FG is going to be this length from here to here. So I can already essentially write up what I know. I know that FG is equal to 11. I don't know what GH is, and I know that FH is equal to 15. Now, once I have some things that I know, I'm going to plug it, because I can't solve this because there's too many variables, but now that I have two pieces, I can go ahead and plug them in and I can solve that. So since I know FG is 11, I'm going to plug in 11 for FG. I still don't know what GH is. You can call it X, you can call it question mark, you can call it whatever you want, but I like to leave it as GH, because then I know exactly which segment, the measure of which segment I'm talking about. And then I have FH, which I know is 15. And from here now, it's just a simple algebraic problem where I can't move the G and the H apart from each other. That doesn't make any sense. But this is treated as kind of one whole number or one whole variable. So now all I'm going to do is I'm going to subtract 11 from both sides. Right? And I get that GH is equal to 14. So, oh, wow, did I just do 14? Mr. Kiefer does not know how to do math right now. It's 4. I'm sorry. Okay. So I know that GH is equal to 4. Now, I always recommend you guys check and verify because you just never really know if this is the second time I recorded this video because I made a big mistake in one of the problems later on, and I didn't want to have to go through and edit the entire thing just for one mistake. So I'm re-recording it, which seems a little less efficient, but hey, here we go. In order to check, right, again, I'm just going to plug in all the values that I know. I know FG is 11. I know GH is 4, or assuming GH is 4. I know FH is 15. Right? And if 11 plus 4 is 15 equals 15, I'm good to go, and that's my check. Okay. When we get down to number 5, again, we can use variables, right? So these are quantities. I know this seems like a huge step up from what we just kind of did, but you'll see that it's actually not too bad in comparison. Okay, so if I just treat it the same way that I treated the last one and set it up that same exact way, it becomes much easier. So I have K, J, and I, which are collinear, and I know that J is between K and I, which means the following statement is going to be true. Again, always start off writing this. So I have K, J, plus Ji is equal to Ki. Okay. Now, before I begin, let's just kind of talk about what I know. I'm going to put these quantities in parentheses because so I know that they kind of stay attached. I know that Kj is going to have a length of 2x plus 2. I know that Ji is going to have a length of x minus 2. And I know that Ki is going to have a length of 12. So once I have all my pieces, I'm going to substitute them in. So I have Kj is 2x plus 2, and I'm going to keep them in parentheses, plus Ji, which is x minus 2, which is equal to Ki, which is 12. And again, now this just becomes part of our a very simple algebraic problem. So what I want to do is since there's no multiplication on the outside of the parentheses, nothing's being multiplied inside the quantities, I can just drop the parentheses essentially and treat this like it was just a normal addition or subtraction problem. So I'm just going to be able to combine like terms. Well, I've got my variable term, which is 2x, and a variable term, which is x. I'm going to combine them using addition, and I get 2x plus x, which is 3x. I've got 2. I'm going to combine it with negative 2 through addition. So 2 plus negative 2, which is going to give me 0. So I don't need to write anything down for that. And I know that this whole thing is going to equal 12. Divide by 3 like normal, and I get x is equal to 4. Now, because the problem did ask for me to just simply solve for x, I can go ahead and be finished, but you always want to make sure that you check your work. Okay, so when I'm checking my work, I like to put a check in, 2 parentheses. I'm just going to plug in I'm going to plug it in for each individual one before I plug it into the main one. Okay, so I know kj then, which is equal to 2 times 4 plus 2, right, which is 8 plus 2, which is 10. Now, if kj is 10, you guys should be able to figure out that if ki is 12, that ji needs to be 2 when I solve it out. So let's double check. Ki, sorry, not ki. We already know what ki is. Ji is equal to 4 minus 2, which does in fact equal 2. So I have 10 and 2, and again, I just plug them in. I know kj is 10 plus ji, which is 2. Does that equal 12? Well, 12 equals 12, so I'm good to go. Okay, so then x does in fact equal 4. We're going to number 7, which again seems a little bit more difficult, because now what we're doing in this one, we just asked to solve for x. This one, we're asked to find a very specific length. So we're asked to find the length of qs. Well, I've got a variable term here and a variable term here, so it kind of seems problematic, because I can't just guess and check and see what qs is. So I have to use the idea of the betweenness of points in order to solve for it. Okay. Again, nothing's going to change with how I'm setting up this problem. I'm still got 3 collinear points. I know R is between Q and S, which means then that QR plus RS is equal to QS. Okay. Now QR, we have a length of x plus 1. I know RS has a length of 9. And I know QS has a length of 7x minus 2. Okay. Now, there's not much I can really combine on this side other than the 1 and the 9, because there's nothing multiplying the parentheses, so I can just go ahead and kind of solve this out like I normally would, and I get x plus 10 is equal to 7x minus 2. Now, I don't like having negative variables, so I'm going to leave the 7x there. I'm going to subtract x from both sides, and I get 10 is equal to 6x minus 2, and then I'm going to add 2 to both sides, and I get 12 is equal to 6x, divide both sides by 6, and I get x is equal to 2. Okay. Now this is important. I'm not gonna box this, because this is not my solution. This is just what x equals. My whole goal is to find what qs is. Well, qs has a length, right, of 7x minus 2. Okay. So if you set this up like that, like we did the last two, and wrote it out like that, then you already have this equation kind of set up. So I know that qs is equal to 7x minus 2. Now I've got to plug in x in order to solve for what qs is equal to. Well, 7 times 2 is 14 minus 2, which is equal to 12. So if x is equal to 2, I know qs is equal to 12. Okay, and again, we can check this out, or check this by saying, well, we know qs is we're assuming qs is equal to 12, right? We know that rs is equal to 9, and now we kind of need to solve for what QR is. Well, QR is x plus 1, so QR is 2 plus 1, which is 3. So now I really just need to check QR, which is 3, plus RS, which is 9. Does that equal 12? Well, 12 equals 12, and I'm good. So always make sure that you double check your work and just kind of plug things back in. Don't just get to like x equals 2 and be done, or don't just get to QS and be done. Always want to double check, because that's how I found the mistake in the last time I recorded this video. So hopefully you guys don't run into that problem. Anyway, so you guys now have assignment for the rest of the day. You're all prepared. So I recommend whenever you set up these between points or betweenness problems, you always set it up using the geometric way, which is QR plus RS is equal to QS, so on and so forth. Anyway, all right, thanks for watching. Yeah, go ahead and get to work.